The eighth lesson in Module 12 is about slope and equations of lines. The learning objectives of this lesson are classify lines as parallel, perpendicular, or neither by comparing the slopes of the lines, and then to classify lines as parallel, perpendicular, or neither by comparing the equations of the lines. Just by the slopes or by the equations, you can tell whether the lines are parallel or perpendicular or neither. So we will see how to do them. Before that, keywords of this lesson are parallel, perpendicular, slope. We have come across this before already. Now we will go through them again. Slope criteria for parallel and perpendicular lines. Now, slope is the ratio of the change in rise, that is y coordinate, that is dy, rise is always vertical, to the corresponding change in the run means horizontal. So dx, dy by dx is slope. Now, slope criteria suggests a method for proving the relationship between lines based on the comparison of slopes of the lines. So now, over here, this is very important. Let us see, for example, based on the slope criteria. If there are two lines, how are they parallel or how are they perpendicular? If the slope is same, if the parallel lines have same slope, then it is parallel. If the two lines have same slope, then it is parallel line. This is slope criteria. Basically, based on the slope or the relationship of the slope, we can tell what lines are they. Same way for perpendicular, we can tell perpendicular slopes are based on negative reciprocal, or imagine you have the slopes of these two lines. Now, I'll just give you example 1 by 3 and minus 3. Whenever you multiply these two slopes, you must get negative 1. So if the product of the two slopes are negative 1, then they are perpendicular. So this is the thing. Now we will see a problem over here. Determine whether line AB and line CD are parallel, perpendicular, or neither for A. The point A is at 3,6, B is at minus 9,2, C is at 5,4, and D is at 2,3. Graph each line to verify your answer. So first we need to graph, that is point A is at, how do we graph is, where is this, this is the x-axis, the horizontal, and y the vertical. Over here the scale is 2, 4, 6, so 3 is somewhere over here and the 6 is over here, so this is the first point A. B is minus 9 over here and 2 is over here, so B. And then draw a straight line between those 2 points. Same way for C. C is 5, that is somewhere over here, and 4, so this is the point. And D is 2 and 3, that is over here. Draw a straight line. You will get the two lines. So looking at this, you can tell it cannot be perpendicular. It should be parallel or not parallel. So you can, eliminate this completely. You can eliminate this completely. You can just tell whether this or this. Now let us see how do we exactly find it. Use the slope formula and find it. You know the 2 points. So this will be x1, y1, x2, y2. So now use the formula y2 minus y1 divided by x2 minus x1 and find it. So y2 is 2 minus 6. Same way, minus 9 minus x1 is 3. Put it in the calculator, you'll get the answer 1 by 3. Now same thing, do it for the other line. See, so other points, CD, x1, y1, x2, y2, and you will get the answer. So over here it is y2 is 3 minus 4 divided by 2 minus 5. Put in the calculator, you will be getting the answer 1 by 3 and 1 by 3. Here you can see the slopes are same, therefore they are parallel lines. So this is how we get it. So I'm sorry, this is not pines, it's lines. I just realized it. Okay, it's parallel lines. Anyways, now let's go to the next problem. Determine line relationship when given graphs the graphs are given over here in this case. See, in this previous one, the graphs were not given. We had been given points. Now, let us see. They are asked us to find whether RS and TU are perpendicular, parallel, or neither. So obviously you can rule out parallel because they're intersecting. This is not true. It should be the perpendicular or neither. Let's see them. And the points are there. See the points T, U, S, and R. Same thing, just like what we have done before. You need to use the slope formula. Let's first write the points. For line RS, the R points are -8, -3, S is 6 and 7. Same way for T, -6, -4, 6, 0, 0. Now use the slope formula and write it. X1, Y1, X2, Y2. Just substitute and solve over here. You will get uh, y2 minus y1. y2 is 7 minus of -3. So use the bracket divided by 6 minus of -8 equals to, over here it'll be 10, and over here it'll be, this minus minus becomes plus. So it'll be, add them all, 10 by 14, it's 5 by 7. Same way, find the slope over here for the next line. 0 minus 6 and 0 minus of -4 will be -6 by 4. It's -3 by 2. It's not over. Now you need to multiply these both slopes. You got the slopes, multiply them. Now when you multiply over here, you're getting the answer -1.07. This is not perpendicular. If it was to be perpendicular, you had to get exactly -1. But this is not -1, it's -1.07. So they're not perpendicular. So they're neither. Basically, they're neither parallel nor perpendicular. So same way, let's do one more problem. Over here again, the graphs are given. The line EF and DG. So same like what we have done before. So what I would ask you now is, please pause the video, try this by yourself, and then continue with the explanation together. I hope at least some of you have tried to, try this problem. But now we will just quickly look at this. EF, write the given points, E and F. DG, write the given points over here. Then use the slope formula, y2 minus y1. So over here, this is x1, y1, x2, y2. Just apply over here, -1, -6 divided by 6 minus 3, and write the answer. Same way, slope of dg, it'll be 5 minus of -1, 12 minus of -2. Get the answers. Now, over here, all you need to do is multiply the slopes, multiply them. When you multiply them, we are getting exactly -1. How? Because the 7 cancels over here, numerator, denominator, 3 cancels, only -1 remains. Therefore, they are perpendicular lines. So this is so these are perpendicular lines. That's the answer. Now we will go through the line equations. First, we will go through non-vertical line equations. There are two non-vertical line equations. The first one is slope-intercept form, which we have come across before. That is given by y equals mx plus b. Whenever you have given the equation like this, y equals 3x plus 8, you must understand this is in the slope-intercept form, where y is alone and this, whatever is the coefficient of x, is the slope, and the number, the constant which is added to it, is the y-intercept. So this is about it. Now the other equation is point slope form. Now point slope is given by y minus y1 equals m of x minus x1. You can see over here y minus y1 is over here any number. For example, the point 3, 5. So the y1 will be the y value of the point. So phi equals -2 of x minus 3. The slope is -2, and these are the points. So from these, we can directly get the slope. If we understand this thoroughly, we can easily find the slope. And then horizontal and vertical line equations. Always remember the straight line over here is the vertical line, and it is given as x value because when it's a straight line, where does it intercept? It intersects the x. So over here, x is equal to -2 because it only touches the x-axis. Whereas the horizontal line, where does it touch? It won't touch the x-axis, it touches the y. So y is equal to -3 in this instance. If you're thinking what if the line is over here, then over here we write it as y is equal to 0 because it's touching all the x values, but where does it touch, intersect at y? That is the point in consideration. Now there are few important things which you must remember. Whenever we have two vertical or two horizontal lines like this, they are always parallel. If it's like this, only two horizontal lines, they are always parallel. And if one vertical and one horizontal, like this question over here, like this example over here, then it is always perpendicular. So please remember that, because over here, whenever they are when it's a vertical and horizontal, it's perpendicular. Whereas if it's two vertical, it's parallel, or two horizontal, sorry, two vertical or two horizontal, it is parallel. Now then, we will see some problems. Determine whether each pair of lines is parallel, perpendicular, or neither. Now over here you have the slope-intercept form and the point-slope form. So we need to analyze the given function. This is the slope-intercept and this is the point-slope. From this we can easily extract the slope. See, the slope over here is 3 and over here is -1/3. So they're not the same, so multiply them. Just multiply them, and what is the answer you're getting? It's -1. So they're perpendicular. If at all you multiply the two slopes and you get -1, it is perpendicular. Now, next one over here, another problem. We have got y is equal to 3 and x is equal to 1. So now, this is a horizontal line. Whenever y is equal to 3, that means it's at 3. This is a horizontal line. At 3 and x is equal to 1 is a vertical line. So over here we have horizontal and vertical line. Then we need to find the slope. Over here in the first case, the slope is 0. See, whenever there is a horizontal line, the slope is 0. There is no slope. And whenever it is a vertical line, the slope is undefined. It's basically undefined or infinity. It's not defined. So these are the slopes, but you do not need the slopes when it's vertical and horizontal. Why? Because we know that in whenever we have vertical and horizontal line, they are always perpendicular. So that is the answer. Now there is a check problem. I highly encourage all of you to pause the video now and try to do this by yourselves. I hope you guys have at least tried the problem. You can see the first equation over here is a point slope form. The first is point slope form, and over here we have slope intercept. From this we can easily check the slopes. The slopes are the same, therefore they are parallel. That's it. Again, I'm so sorry. I changed the previous slide, but I just realized again I have not changed it over here in the slide. I'm so sorry. It is parallel lines, not lines. Let's do one more check problem. Here again we have, now it's x is equal to -2. So it's somewhere over here, and x is equal to 4. My vertical lines are not so vertical, but I hope you understand what I mean. This is x is equal to -2 and x is equal to 4. So you can see there are two lines over here. Now these are always parallel because they don't intersect. The slopes are same and they are always parallel. So now these both are vertical line. You do not need to find the slope. See, always vertical lines are parallel. I hope this is clear. Just remember, If the equations are point slope or slope intercept form, see the slopes and then verify whether they are parallel or perpendicular. If it's only vertical lines or only horizontal lines, they are always parallel. But if it's one vertical and one horizontal, x, and one is y, then they are always perpendicular. Now we will solve real world problem. We will use slope to graph a line. Mariam is designing a park using grid paper. She wants to build a sidewalk that connects with the fountain at P 0, 1 and is perpendicular to the existing sidewalk that passes through points Q and R. Graph the line that represents the new sidewalk. So what it says is, see, this is a fountain. You can see the fountain over here, a small one, at this point P of 0, 1. And there is an existing sidewalk at Q and R. These are the points. And then there is a new sidewalk that is, the new sidewalk to be built from the fountain which touches over here, which will be perpendicular. So this is what it says. So you need to draw this line. Basically, you need to find the slope of this sidewalk. That is what is required. But we do not know the slope of this line. So first we will find the slope of this sidewalk. That is this line. So now what we do is use the slope formula and find. Over here, this is x1, y1, x2, y2. And substitute and you will get the slope. Even if you interchange this, say for example, I take this as x1, y1, this as x2, y2, you will get the same answer, no worries. But over here, generally the first point is q, so x1, y1. This is x2, y2. So y2 is minus 6 minus minus 2. And over here, x2 is 0 minus negative 6. Put it in the calculator, you'll get the answer minus 2 by 3. What next? Find the new slope of this. Find the slope of the new sidewalk. Now we know that it must be perpendicular. So what do we know about perpendicular lines? If there are perpendicular lines, when we multiply the slopes, they will be -1. I'm so sorry, this must be -1. I missed out the negative sign. I will change it in a while. So now, what do we know? When we multiply the slopes, it must be -1. We know one slope. So another slope is unknown. Let's take it as m. Multiply it with -2, you must get -1. So just solve that. So it basically is -2 by 3 when you multiply with m must be equal to -1. So the signs cancel and this 3 goes to the other side. M will be 3 to the above and 2 to the denominator. So this answer will be 3 by 2 or 1.5. So this is the thing. Now we found the slope of the new sidewalk. Now if you want to graph it, you can graph it easily. Say for example, plot the first point, plot the point which we know, that is this over here, the fountain 0, 1. And now what does the slope tell us? Dy by dx. That means it has changed in the x direction by 2 units and y direction by 3 units. Since it's positive, x will be in the right side, right side 2 units up, 2 units right and 3 units up. So up by 3 units. Now what it means is you need to move 2 units to the right from here 0, 1 and 2. So from 0 you'll get 2 and 3 units up. So it'll be 1, 2, 3. So you will reach 4 because it's already at 1. 1 plus 3 is 4. 0 plus 2 is 2. So you will get these 2 points, right? Now all you need to do is draw a straight line connecting those 2 points. That is the graph for the new sidewalk. So this is the thing. And now we will see another problem where we need to write the equation. In the previous problem, it was just the graph. That's it. Now we will write the equation over here. Write an equation in slope-intercept form for the line parallel to y equals -3 by 4 x plus 3 containing the point -3, 6. First of all, let us understand what is the graph. Sorry, slope. What is the slope, not the graph? The slope over here, the equation is given minus 3 by 4 x. So this is the slope, minus 3 by 4. Okay. Now, we know the slopes will be same for parallel lines, but we need to write the equation in the slope-intercept form. If we recall the slope-intercept form, let us see the slope-intercept form over here. Y is equal to mx plus b. We know the slope is m. Slope is over here. How do we find the b? That is the y-intercept. How can we find it? They have given us the points x and y, isn't it? So now what you do is substitute the x and y values and the slope, then you can find the b value. So all you're doing is the y value is 6, substitute over here, equals minus 3 by 4, that's the slope, and x is minus 3 given. Now find the b value. Look over here, you need to multiply these both. You will get 6 equals minus becomes plus. So I'll not write it. It's plus 9 by 4 plus b. Now what you have to do is to find b, you need to subtract 9 by 4 from 6. So this is the thing. How do you do it? You can do it directly in calculator. Otherwise, the denominator is 4. So 6 multiplied by 4 divided by 4 minus 9 by 4. You will get 24 by 4 minus 9 by 4. So always the easier way to solve, fractions is, what is the denominator over here? It is 4. So multiply and divide by 4 to the other side because it's only single. There's no fraction over here. So what happens over here is, when there is no fraction in one side and when there is a fraction on the other side, this is the easiest method, I feel. Whatever is the denominator, multiply and divide. Now, you have equated the denominators, and over here you will get 24. And this is, you're just manipulating this. Divide and multiply by a same number is 1. So there is nothing wrong in this. 24 by 4 minus 9 by 4. Now, denominator is 4. 24 minus 9 will be 15. So answer will be 15 by 4. So over here, the b value is 15 by 4. So that's about 3.75. Now we have to write it in the slope-intercept form. We know the slope, we know the y-intercept, and all you need to do is put it in the slope-intercept form. Y equals minus 3 by 4x plus b. So this is the answer. So this is how we can write either a perpendicular or parallel line equations just by knowing the slope. Remember one important thing: when parallel lines are there, this is the denotation generally. Okay, anyway, two straight lines is parallel lines. The slopes are same, okay, equal. But if it's perpendicular lines, remember m into m, the two slopes must give you -1. If you remember this, then it's very easy. So that's it. That's the end of this lesson. If you have any doubts, please put them in the comment section and I will try to answer your queries as soon as possible.